Hi, this is Jonathan, and today I'm going to show you how to use WorldWide Telescope to export mountains, craters, valleys, other interesting um, artifacts from WorldWide Telescope, from Earth, Moon, Mars, to be able to print them out with a 3D printer. So first of all, you're going to need WorldWide Telescope. So if you go to worldwidetelescope.org/downloads, and then you download the latest version of WorldWide Telescope, go through the installation process, and then go ahead and launch it. You'll start out with a view of the solar system here, and you'll have your menus up at the top, and down at the bottom here, you'll have look at. And this controls what your view is at. You can go for the whole solar system itself, which basically is actually starts at the solar system and goes out through the universe. But specifically, we're going to want to focus on one planet. Earth, Moon, Mars are the ones that have digital elevation maps that we can use. So we'll go ahead and start out on Earth here. And let's go ahead and zoom in. And we'll go ahead and find Mount Rainier here. Go ahead and center on Mount Rainier. And then go ahead and click on the view menu, and there's a little arrow on the bottom of the view menu that will pop down, and you can see export current view as STL for 3D printing. So we go ahead and click on that, and it's going to show us a default latitude longitude rectangle that it's selected for us. So what we can do is we can either enter into the dialog box over here the north-south extents and the east and west extents if we know the numbers, or we can specifically drag visually and then go ahead and select the area that we want. So when you're highlighted around these arrows, when you can move them, it'll turn to a double arrow to show you that you can actually move. So once I've highlighted this area, I'll zoom in so it's mostly filling up the screen, or maybe just a little bit zoomed in, a tiny bit beyond that. And then I'll click the export button. Now first, let's see that we have density, base, and elevation percentage. And this density is how dense a grid do we want for our STL model. Base is how much extra buffer do we want as the base of this model, because it's going to give us a rectangle with the model of the mountain or valley in it. But the lowest elevation will be 0. If we want a couple of millimeters, or in this case right here we have it set for 10 millimeters, but usually I'll put it like 2 or 3 millimeters. If you have a larger base that you're going to print it over, print it larger, then you might want to have a thicker base, for instance, for flatter areas where the terrain is not as substantial. And so if you want to still have a fairly thick base, you can do that. You can also exaggerate the terrain. So if you have something that doesn't have enough terrain to really look good in 3D model, you can exaggerate the terrain. Now, too much exaggeration will make it look unrealistic, but sometimes people's perception of altitude is such that certain mountains look in 3D a lot shorter than they do in reality. And in some cases, you might want to exaggerate a little bit just for artistic license. Anyway, when you're done, you can click on export, and we're going to go ahead and select our downloads, and we're going to call this Mount Rainier here. I'm going to replace an existing file. That's going to scan through, and it's going to download the data locally, and then it's going to scan through that data and create that 3D mesh. Okay, so we're going to go ahead and close that one for the time being, and then we're going to go back and try one for a planet. And so now we can come into Mars here, and we can go to Olympus Mons, and we can do the same thing here. Go ahead and export for 3D printing, and then we'll go ahead and select the area around Olympus Mons, and then we'll go ahead and export that, and we're going to go ahead and call this one Mars here. And that's going to scan the elevation for Mars and then export our STL file. So while that's exporting the Mars, I'm going to go ahead and move over to Creative Print here, and I'm going to show you a view of Mount Rainier that I've already imported as an STL file and then sliced. And now you can actually see slicing of this. This right here, as you can see in the lowest elevations, this is that base that we had put in here. So this ensures that this doesn't actually touch the build plate and you have some substance. So you can see from the side how this works, and then you can see that it actually looks like a bit of a 3D topo map. And you can exaggerate this effect by, if you have it multi-printing filaments, you could have like every 10 layers have, you know, a black or gray or red or some other filament go alternating with your base filament, so that you could actually have what looks to be a 3D printed topographic map. So here is Mount Rainier. I'll go ahead and delete this for now, and then we'll go ahead and load up the Mars version here, and we can see Olympus Mons pop up. Now here you notice that the resolution on this does not appear to be nearly as good. And so it's like, well, how do we kind of debug this? Well, it turns out that the zoom that we use to export has a lot of impact on the resolution that it picks. So if we zoom, we were kind of zoomed out. If we zoom in a little bit more here, and then you can see that it's resolving the map better, and then we click on export and go ahead and select Mars again. Now it's going to have a much denser elevation map, and then we can see whether we went a little too far on this and are bringing in way too much data. So there's a balance you have to strike on this between downloading too much data and not downloading enough. So at this point, it's actually scanning through the elevation and downloading all of these individual tiled multi-resolution meshes of the elevation map in order to sample that data to have a much higher resolution view to export. So we'll go ahead and let this finish. In the meanwhile, you can see that before there's just not a whole lot of detail to this map, and it just seems to be, you know, not particularly detailed. And so let's go ahead and see when this finishes here. We should have a lot more information on it. And some of those items, just changing the density, if you don't have the, if you don't zoom in to grab more detail, won't really help that much. So we're about there. And this is almost done. And it's now writing the file. And now we'll go ahead and go back to preview here. We'll delete the old one and we'll bring it back in. And if we're lucky, then we should have the much better resolution to this. And now there you go. You can see that there's much higher resolution to that version of it. And then when we click on the preview, you can also notice that the base itself is a lot thicker. This will take a lot of printing. And if you have dense infill, you know, then you're really going to be printing a lot of, using a lot of plastic, and then there's not going to be that much in terms of layer density on the top. So one of the things that this can do is, this is one that you may want to print with a shorter base, for instance. And then also, you know, putting a honeycomb or some sort of fill that will be able to handle the way that the layers are built is a good idea. The other thing too is that you can use adaptive, if you're just printing to get the best look as possible, having very thin layers will mean that you'll have, it'll look a little less like a topo map and a little more natural. So that's some of the things you can do to play with. Let's go ahead and see if we can bring in the moon. And I think we have a crater in here as well that I exported from looking at the moon. And again, this is one here that's resolution is could be a little bit higher if we zoomed in a little bit more, but by the time we actually go ahead and slice this, some of that issue isn't as big a issue anymore, because the 3D printing will just naturally end up making the topo layers, you know, this, you don't want to get much more detail than the thickness of your slices anyway, or you're really not going to benefit from it. Okay, hope you've enjoyed.